Okay, we need to, a lot of people didn't make the class last time, so I'm going to go kind of quickly over what we talked about last time, systems of equations. So it'd be systems of linear equations. Now you're going to want to look at the video because there are a lot of nuances, a lot of things that I'm not going to be able to say as slowly and as clearly as I ordinarily would. But let's take an example. System 2x plus 3y equals 5. The system 6x minus 6y equals 0. A very simple system of equations. I number the equations. First equation will be numbered 1. Second equation will be numbered 2. Those numbers are in circles, so we don't confuse them with something we're going to do arithmetic with. Okay? So I put an underline under those two equations. And what I'm going to want to do is I'm going to want to eliminate x or y between these two equations. To do that, I'm going to multiply the first equation by -3. And -3 times the 2x is going to give me -6x. And that's going to match up with the 6x in the second equation and give me no x's. Because when I add them, they're going to go away. Okay? I could also choose to eliminate y. If I multiply the first equation by 2, I'm going to get a 6y, and that'll match up with the -6y in the second equation. I'm going to choose to eliminate the x for reasons that might become apparent. So I'm going to do -3, and I'm going to write that down, -3 times equation 1. And that means I multiply both sides, every term, by -3. I'm going to get -3 times 2x is -6x, -3 times 3y is -9y, -3 times 5 is -15. Then I'm going to write down just the second of my original equations, which is 6x minus 6y equals 0. And then I'm going to add these two equations. I'm going to indicate that by saying circled 1 plus circled 2. Circled 1 always refers back to the first equation in my previous set. It doesn't refer all the way back to the first equation in the original. Okay, so equation 1 is the circled 1 now in my third step here is the -6x minus 6y equals -15, which is going to be added to equation 2. And they're lined up, so you can just add them. -6x and 6x gives us 0. -9y minus 16y is -15y. And that equals -15. Okay. We solve for y. We have -15y equals -15. Divide both sides by -15. And we get y equals 1. We substitute y equals 1 into equation 1. We get 2x plus 3 times -1 equals 5. Y equals 1, substitutes for the y in the first equation, gives us this. And the arithmetic is simple. We get 2x minus 3 It's not -1, it's 1. Sorry, 2x plus 3 equals 5. And we solve that and we get x equals 1. Okay. Now, last time I think we saw how you can get a system of simultaneous equations from 2 points on a graph. And what you get then is a linear equation, or a system of 2 linear equations. You can review that because we did that earlier in the semester as well as last. Okay, then you should check with the original second equation. Because the original equation is what we really have to satisfy. Well, we get x is 1, so we got 6 times 1, y is 1. Get 6 times 1 equals 0, 0 equals 0, it checks. Okay. We can also check with the first equation. If we solve this correctly, we're pretty well assured. So sometimes we'll just stop here, but if you want to really be sure, plug it into the first equation, make sure it works in both equations. And this is going to give you the x and y coordinates where 2 lines intersect. Okay? Where the equation 2x plus 3y equals 5 intersects equation 6x minus 6y equals 0. Okay. Does that make sense? Pretty straightforward. Okay, now if we have 3 equations in 3 unknowns, and I want to check because I'm actually doing this in 3 different courses. Okay, now we're going to look at a system of 3 equations and 3 unknowns. In class last time, I did a video where I solved this system. Okay, and the only thing I'll say right now is I started by putting these 3 equations in different order. Okay, but I have equation 1, equation 2, equation 3. I wrote equation 3 first, then equation 1, then equation 2. I can put them in any order. They're the same system of equations. They'll have the same solution no matter in what order I list them. So I'm going to have x plus 2y plus 3z equals 0. 2x plus 3y minus 4z equals 9. And 6x plus 2y plus 5z equals 0. Okay, same system, listed in a different order. And the reason I like that is because now I've got a 1 in front of my x in the first equation. Okay, and that's something we always want because now what we're going to do is we're going to, and if you look, you see that if I multiply the first equation by -2, I'm going to have a -2x here. So when I add the first equation to the second, my x in the second equation is going to go away. Okay? And I can also then multiply the first equation by 6, -6, and add it to the last equation, and x's will go away here. So then I'm only going to have 3y minus 4z equals 9, 2, actually my y's and z's are going to change, but when my x's become 0, then I'm just going to have 2 equations in the unknowns, y and z. Okay? Then if I eliminate y from the second equation, I'm going to have just an equation in z, and I can solve that. Then I can plug my solution back in to one of the previous equations and get y, and then I can plug the z and the y back into one of the original equations and find x. Well, that's the process that I went through again in detail in our last class. The augmented matrix looks like this, okay? So I have row 1, row 2. I'm going to rewrite the augmented matrix same way I did with the equations. So that I have my 1, 2, 3, 0 in my first row, and then my 2, 3, -4, 9 in my second row, and my 6, 2, 5, -1 in the third row. Then I'm going to do row 1 of the previous matrix, which was row 3 of my original, but I'll ignore that now. Row 1 of this matrix is just going to not be changed. Still 1, 2, 3, 0. But then I want to do -2 times row 1 added to row 2. And then I'm going to do -6 times row 1 added to row 3. Let's see where that gets us. Now, when I'm working out a system, a lot of times I've got to go over to the side and do side calculations. Okay? For example, if I want to do -2 times row 1, or -2 times the first equation plus the second equation, I write that off to the side. I don't write it below here. I don't want to interrupt the flow of my solution. So I do my side calculations off to the side. Similar to what I'm going to do here, my side calculation for -2 times row 1 plus row 2 -2 times row 1, and probably off the screen, yep. Okay, -2 times row 1 is what? I'm going to write that kind of small because I don't have a lot of room over here. But row 1 is 1, 2, 3, 0. If I multiply each of those by -2, I get -2, -4, -6, 0. And then row 2 is 2, 3, -4, 9. I add those together, I get 0, -1, -10, 9. They might not even be able to read that, but what I've done is I've just done this arithmetic over here, not down here where it'll confuse everything. So what I see is -2 times row 1 added to row 2 gives me 0, -1, -10, 9, assuming I've done that correctly. Now, ordinarily, I'd want to have a lot more room over here so I can do more side calculations. But I've also got to do -6 times row 1 plus row 3. And I want to write out the plus row 3 here. Negative 6 times row 1, we multiply 1, 2, 3, 0 by 6. We get negative 6, negative 12, negative 18, 0. That's negative 6 times row 1, because that's what we're going to do. And then row 3 is 6, 2, 5, negative 1. Now I add those two, negative 6 and 6 gives me 0, which is what I want. Negative 12 and 2 gives me negative 10. We have 18 and 5 gives me negative 13. 0 and negative 1 gives me negative 1. So that's what I now write over here. Okay. So that's going to be 0, negative 10, negative 13, negative 1. That makes sense? I'm just playing with numbers. But my goal is to get a 1, 0, 0 in my first column. And you'll see why in a minute. Okay, now, in my next step, I like row 1 the way it is. I'm going to leave it. I could combine some stuff, but I'm not going to. The only change I'm going to make is I'm going to multiply row 2 by negative 1, so I get a 1 here. Okay? I want a 1 here. So I get row 1 is 1, 2, 3, 0. Row 2 is going to be 0, 1, 10, negative 9. I didn't write that off to the side. I just carefully made sure I multiplied every number in the second row by negative 1. And the negative 1 and negative 10 become positive, and the 9 becomes negative. And then the third row is 0, negative 10, negative 13, negative 1. Now, my next version of the matrix, I'm going to have the first row there, the second row there. And now the third row is going to become third row plus 10 times the first row. You see I've got a 1 here and a negative 10 here. If I multiply the second row by 10, it's going to match up with this negative 10 and give me a 0 there. Okay, just like eliminating y between the two equations. Okay, so I'll write that off to the side. 10 times the second row is 0, 10, 100, negative 90. Something screwed up. I don't like that. But I'm going to live with it anyway. Then the third row is, that's all I need here. The third row is 0, negative 10, negative 13, negative 1. When I add these, I get 0, 10 and negative 10 is 0, 100 negative 13 is negative 87. and negative 90 minus 1 is negative 91. And there's something wrong in this, but the process is what it is. So for this matrix, I'm going to write down just row 1, 1, 2, 3, 0. Row 2, 0, 1, 10, negative 9. And then the third row plus 10 times the first. Right here is the third row plus 10 times the first. This is the row that's going to go here. 0, 0, negative 87, negative 91. And that's off by a little bit. I'm going to try to find my error, but I'm going to turn off the camera for a second. These two numbers should match up if I did everything correctly, and they don't quite match up. So let me see if I can spot an error in my arithmetic. Okay, so if I get the matrix down to this form, this is called upper triangular form. It's almost upper triangular form. Let's put it in upper triangular form, okay? I got 1, 2, 3, 0 for the first row, 0, 1, 10, negative 9 for the second row, and 0, 0, negative 87, negative 91. But what I want to do now is I want to take row 3 and divide by negative 87. Dividing negative 87 by negative 87, I get 1. Dividing negative 91 by negative 87, I get 1.04 approximately. Now this system tells me, first row tells me that x plus 2y plus 3z equals 0. That y plus 10z equals negative 9, and that z equals 1.04. Then we back substitute to find x and y. Now this is an error. And maybe in second equation, probably as well. And I can't trace down the error. I can't find it. So I did something wrong. You can start with this system and that works. What I should get down here for z should be negative 1, negative 87, negative 91. One of these should probably be positive, and the numbers should actually match. I got a good idea what probably happened, but I can't spot it. The actual solution, what you would know from having done the system in this manner without using the augmented matrix. I think it's x equals 1, y equals 1, z equals negative 1. Got something close to 1, wrong sign. That indicates I reversed a sign someplace. Okay. So I suggest you work through this as an example. Because most of the steps are correct. It's just that the arithmetic somewhere got haywire or copied a number down wrong, but I check that, I can't find it. Can't find it. So that's how you can reduce a system to upper triangular form. You see how neat this works. If you know what Z is, you plug it in here and you can solve for Y. Then you know Y and Z, you can plug them in here, and the only thing you don't know is X. You can solve the equation. So that's the key to the system. And again, that's what you get. If you've got a 0 here, you're just going to have a Y plus something. And 0, 0 here, you're going to have an equation for Z. Okay? So your aim is to get a 1 here and then wipe out all the numbers below it, and to get a 1 here and wipe out the number below it. You'd also wipe out the number above it and save yourself a later step, but not going to get into that right now. Okay. Now, what I want to do today, and I'm going to do it using the board that I made for the support course. Find everything and get them in order, that is. Okay, so I'm going to pause for a second. Okay, now we just basically reviewed what we did last week when a lot of people didn't make class. And I think you need that review. Okay. We're going to talk about matrices. And we're going to talk about matrices. Ultimately, we can write that system of equations as a matrix equation, the system that we just solved. And we'll end up by doing that if time permits. Okay. I'm going to have you all work on a couple of things just to make sure you're getting this, because this is what's kind of new today. Okay. First thing you got to know is the essence of what you do for multiplying matrices, which is the most important operation on matrices, is you multiply a row by a column. What's a row? Well, if I put a square bracket here and a square bracket here and put some numbers, just a list of numbers, no commas or anything, just numbers, then I've got a row. It was that way. Okay. Now this is a short row. It's a row with two numbers, 2 and 4. So it's left bracket, 2, 4, right bracket. Okay. That's actually a small matrix. It's a row matrix. And I'm just going to call it a row right now, and we'll use the word matrix a little bit later. And then we have a column matrix. -3 at the top, 5 at the bottom. There's a column. Okay. To multiply a row by a column, the row has to be on the left, the column has to be on the right. And to multiply these, we just do the most obvious thing you could. Take the first number in the row, multiply it by the first number in the column, and then take the second number in the row and multiply it by the second number in the column, which means we're going to multiply 2 times -3, and then we're going to multiply 4 times 5. And that's going to give us 2 multiplications. We do the arithmetic, and we get a result. Okay? So I'm going to ask you to multiply 2 rows. I mean, to multiply a row by a column. Can you do that multiplication? You know, set this up so you can see the first example if you like. So take a minute, just write that out. Don't stop to take notes on what I already wrote. Just do it so we can see if you got the idea and then move on. Okay, now everybody made a jump because these rows and columns only had two numbers in them. And I gave you a row and a column with three numbers in them. Well, I figured you'd know what to do. Okay, but let's be sure. And everybody did. First number times first number, one times two. Second number times second number, three times one. Third number times third number, negative two times negative three. That equals two plus three plus six, which is 11. Okay, so no problem. Okay, now I've got an example here, and I'm not going to let you puzzle it out. What's the problem with this? Yeah, you got the first number times the first number, that's going to be fine. Second number times the second number, that's going to be fine. But my my row has three numbers in it. The column only has two numbers in it. So I can't do the third number in the row by the third number in the column. Well, I wrote that out. 2 times 2 plus negative 4 times 3 plus 6 times, huh? I could have used WTF, which stands for what's this foolishness? Um, and we can't do this. These things don't match up. Matrix multiplication is not defined. Or, yeah, row times column is not defined unless the length of the row is the same as the length of the column. Okay, well, now let's see what you can do here. Um, what do you think you're going to do with that? Notice that the first row is the same as what we had here, and the column is the same as the one we had here. So you can kind of shorten the calculation. See what you think you would do with that. Okay, everybody multiplied the first row by the column, then they multiplied the second row by the column. Now, what you actually do with those, it's going to give you a matrix. When you multiply the first row by the column, you get 11, just like you did before, right? Because it's the same. So we can write that one down. 11 goes in row 1. And it goes in column 1 because you used row 1 and the only column you got is column 1, right? So row 1 times your column, which is column 1, goes in row 1 and column 1 of a new matrix. Then what you get for the second multiplication, well, I don't know, what do you get? You get 2 times 2 is 4 and 4 and negative 18, you get 10, right? Negative 10. Everybody get negative 10? Or am I doing it wrong? Let's see. 2 times 2 is 4. 4 times 1 is 4. That's 8. Oh, negative 6, you get 28. Put a negative. Am I right this time? 25. 8. Yeah, 26. Okay, I only saw 5. I've seen the 6. Okay, so you get 26, which is kind of coincidental, because that's what I got when I did one before. Okay, so this is Row 2 times column 1 gives you this. So that goes in row 2 and column 1 of your product matrix. Okay? Now let me give you another one because y'all are doing really well. Now, what you didn't know that you were going to put those numbers into a matrix. So the only thing that I'm doing that you didn't know how to do, and now you do, is you put these things into a matrix. If it's row 1 times column 1, it goes into row 1, column 1. If it's row 2 times column 1, it goes into row 2 in column 1. Okay, so let's try this now. Multiply rows and columns, and you multiply every row in the first matrix by every column in the second matrix. Okay. Okay. Now in the video I did for the support course, I do this much more slowly and in more detail. Okay. But here's the pattern. When I multiply row 1 by column 1, I put it in row 1, column 1. When I multiply row 2 by column 2, I put it in row 2, in row 1 and column 2. Okay. Just getting tired of writing those fancy ones. Okay. So everything from row 1 goes this way. Everything from column 1 is here. Everything from column 2 is here, right? So when I multiply row 2 by column 1, it goes here. Row 2 times column 2 goes here. Now, I think everybody probably got the right numbers. Well, row 1 and column 1 are the same as what we did before, so I know we've got 1126 here. And once you know that, it's pretty obvious where the rest of them go. So row 2 times column 1, 2 times 4 is 8, 4 times 2 is 8, and -6 times -2 is 12, which gives us 28. Did you get 28? 26. Why do I keep counting 28s and 26s, and why do I keep messing them up? 2 times 4 is 8, and 8 and 12 is 20. No. Do I really get 8? 2 times 4 is 8. 4 times 2 is 8. So I get 2 8s and I get a 12. I think it's 28. You get 28? You get 26. There was a time when I was really good at mental arithmetic, but apparently, what am I not seeing? 8 and 8 is 16, and 12 is 28. I'll put a question mark next to it. I still think it's 28, even though I have my doubts because I trust you guys and you both got 26. Okay. And then, oh, wait a minute. Did you get 28 for this number? Because I was doing row 2 times column 2. And that's where I think At row 1 times column 2 would be 4 and 6, which is 10. Well, no. Row 1 times column 2. 1 times 4, 3 times 2, negative 2 times 2. That ought to be 4 plus 6 plus 4, which is 14. Well, this is what I get. The point is, multiply the first row by the second column. That number, which I think is 14, goes here. Should be. Okay, I'm going to write them out. Row 1, column 2 is 1, 3, negative 2, multiplied by 4, 2, 2. Which equals 4 plus 6. Well, 1 times 4 plus 3 times 2 minus 2 times 2, which equals 4 plus 6. It should be a negative 2 down here. 2 times negative 2. And plus 4, which is 14. 2, column 2 would be 2, 4, negative 6, multiplied by 4, 2, negative 2, which equals 2 times 4, plus 4 times 2, minus 6 times negative 2, which equals 8 plus 8 plus 12, which I still think is 28. Okay, so check your arithmetic, but this is no problem. If you did anything wrong, you know how to fix it. If I did anything wrong, I really do know how to do it. So we're all going to be okay, okay? I do apologize. I had a little sleep deprived, but got a pretty good night's sleep last night. I shouldn't be. 2 nights before that were kind of short. So I might still be feeling the effects. No excuse. There they are. Okay? So fix it if necessary. That's it. Okay, well, I think you got the pattern. I don't think you're going to have any trouble multiplying matrices. Okay, now here I did a couple more examples. I don't have to do them for you. You can multiply this by this. You would have no problem because you had no problem. The first one I gave you, that type. And then I gave another one, which is of the same type we have here. Just get different numbers. You can use it for practice if you want and match up the numbers and see if they work. Okay, and then I did 3 by 3. Well, sorry. This is called a 2 by 3 matrix, 2 rows and 3 columns. This is a 3 by 3, 3 rows, 3 columns. Okay. So if I take the first row, I've got 1, 2, 3 possible columns to multiply by. So I'm going to get 3 numbers. The numbers are pretty obvious. Again, check my arithmetic. It's always fun to find mistakes. Okay. And then the second row times each of the 3 columns. Well, I get 3 numbers, and those numbers go in the second row in the appropriate column. Okay. And I think you've established that pattern. I think if I'd have given you this, you'd have done it correctly. Okay. Now, the big thing, and it is a big thing, all this stuff over here isn't relevant to this class because we kind of skipped all that. and it goes with the previous board. So I'm going to get it out of the way just quickly to avoid any distraction. Also give us a little room if I want to write something else down. Probably won't. Very simple example. And this is what I did after y'all came in a little bit early. I had to wrap up what I was doing before. But we started with the equation 2x plus 3y equals 7, 4x minus 5y equals 13. And I said that, well, this can be written as a matrix equation, 2, 3, 4, negative 5 multiplied by xy equals 7, 13. So without looking ahead, I want you to actually do that. I want you to just do this multiplication, 2, 3, 4, negative 5. Just two rows multiplied by a column. Just write out what you get. You don't have to do a lot of arithmetic this time. Okay, everybody's really good with this. This equals 2, 3, first row multiplied by first column xy means 2 times x plus second number times second number, 3 times y. Or the second entry times the second entry, since y stands for a number, but it isn't really a number. So it equals 2x plus 3y, and then it equals first number times first number, second column, 4x, 4 times x, and negative 5 times y. Now, I don't remember if you wrote down brackets, but you do get a matrix, okay? So you always do want to put the brackets around it if you have a matrix. Now, my equation said that this was equal to 7/13. 7/13, the column 7/13. So this should be equal to the column 7/13, right? Well, if this matrix is equal to this matrix, then the number in the first row here has to equal what's in the first row, right? So 2x plus 3y is in the first row of this matrix, and 7 is in the first row of that matrix, so they've got to be equal. And the 4x minus 5y is in the second row of the left matrix, and it's in the second row of the right. At 13 is in the second row of the right matrix. So now we have just two equations, right? And that shouldn't be a big surprise because it's the same two equations we started with. Okay. Now I just wrote over here, and this is kind of walled off from the rest of it. I could also have written this as an augmented matrix and reduced that augmented matrix. Okay. And I would have gotten a solution. Once you see that the matrix equation can be written in this form, now that's as far as this course officially goes. But since y'all are doing really well with this, I'm going to confuse you. No, I'm going to just show you. You're not going to be responsible for this, but I probably will put it as an optional question on the exam. If you do it, that's worth. If you get that one and you miss some other problem on the test, I'll throw out the other one and give you credit for this one. Your matrix equation, a matrix equation, could be written as AX equals B. Like here. This is A, and we'll call this big X. This is a little x, this is a big X. Let's make sure that big X doesn't look too much like a little x. Give it kind of an Egyptian look. Okay? So big X is like your XY, right? You do an inverse matrix. And you multiply both sides of this equation by the inverse matrix, which is analogous to dividing both sides by the same number. But the inverse matrix isn't involved with division. Okay? I'll show you how to get the inverse matrix. Well, that gives you and I said you multiply both sides by the inverse matrix. A inverse B, that's what's going to give you the numbers. Okay? There's an associative law, A inverse times A times X equals A inverse B. Now there's this thing called an identity matrix that I'm not going to talk about except when I do the inverse. But this gives you the identity matrix, which means it's like 1. So when we multiply it by X, we just get X. So our X equals A inverse B. So if we know the inverse matrix, all we've got to do is multiply it, in this case, by 713, and we get the solution. Okay? Now, to get the inverse matrix, you write the augmented matrix. Take the original matrix and augment it by the identity matrix, which has ones on the main diagonal and zeros everywhere else. So you just got to upper right-hand corner to left-hand, lower left-hand corner, you got ones, and everything above or below any of that is 0. We reduce that to the form where you have the identity matrix. Um, I'll just use asterisk because you don't know what numbers you're going to end up with here until you do it. This matrix here that you get on the right-hand side of the augmented matrix is A inverse. Only got about 3 minutes, and I doubt that I can reduce this matrix accurately in 3 minutes, but I'll show you what it looks like anyway. got 2, 3, 4, -5, 1, 0, 0, 1. Okay, this is our first row. This is our second row. I'm going to divide the first row by 2. That's going to give me 1, 3 halves, half, 0. I divide all these numbers in the first row all the way across by 2. And the second row is going to stay the way it was. 4, -5, 0, 1. Then, first row is going to stay the way it was. But I do second row minus 4 times the first row. I multiply first row by 4 and add it to -4 times the second. But if I multiply first row by -4 and add it to the second, I'm going to get a 0 here. So I'm going to have 1, 0. But -4 times 3 halves is -6. Added to -5 gives me -11. And -4 times 1 half added to 0 gives me -2. And then -4 times 0, 0 added to 1, we still get 1. Now you see what I'm doing. I've got a 1 here, and I've got a 0 here. I've got this and this, right? Now I need to get a 1 here. Well, that's easy. I just divide the second row by -11. Okay. Well, -11 divided by -11 is 1. -2 divided by -11 is 2 11ths. And 1 divided by -11 is -1 11th. And then finally, I do my first row minus 3 halves of the second row. Should have written that a little bit smaller, but it'll work. I'm going to get 1, 0, 0, 1. Because -3 halves of 1 is -3 halves. When I add that to 3 halves, I get 0. Now over here, I'm going to get messy fractions. I got to do -3 halves of 2 11ths and add that to 1 half. Okay? Well, -3 halves of 2 11ths is -3 over 11, which is -6 over 22. This is 11 over 22. So I think maybe I get 5 over 22 here, along with my 2 11ths. And I've still got -1 11th over here because I'm not doing anything to the second row. But then I got to do -3 halves of -1 11th, which is 33 22nds. No, 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 no. It's 3 22nds. So now question mark because of my arithmetic. Okay. Now y'all can go. You got places to be. I'm going to finish this up so it'll be in the video. You can't tear yourself away. You can stick around, but it's going to take a minute. And all I'm going to do is multiply A inverse by the B matrix. My solution is A inverse B. That'll be 5 20-seconds, 3 20-seconds, 2 11ths, negative 1 11th, multiplied by the B matrix. Now, my original equation was here. The B matrix is what's on the right. That's 7/13. 7/13, the column matrix 7/13. So now I've just got to multiply the matrices. 5 20-seconds times 7 is 35 20-seconds plus 13 times 3 is 39 20-seconds. 2 14 11ths, negative 13 11ths. Add them up, I get 74 over 22, and I get 1 over 11. Now, I've done all that without checking anything. I don't trust my arithmetic. I'm not sure that's right. But what's the big X? The big X is my X and Y matrix. Now, 74 over 20-seconds, can't resist. 37 over 11, 1 over 11. X equals 37 11ths. Y equals 1 11th. And that's the solution to this matrix equation. And that goes back to wherever I wrote the original equation. And I guess that's right here. So I'm just going to write again, X equals XY equals 37 11ths, negative 1 11th. So that X equals 37 11ths, Y equals negative 1 11th. And that came from this system of equations. Now let's see. 37 times 2 is 74. Minus 3 is 71. It's close, but there's got to be some error. And let's see, we've got 120, 148 minus 5 is 143. 143 over 11 is 13. Okay, so there's a chance that that solution's right. It doesn't appear to work in the first equation. Okay, my whole point is that's a lot of work to get this solution. There are easy ways to get the solution, but what if you had the same left-hand side, 2x plus 3y, 4x minus 5y, and then you wanted to solve it for a bunch of different right-hand sides. Then the 7/13, you could have a bunch of solutions or a bunch of right-hand sides, and you could solve the equation for every one of those right-hand sides using the same inverse matrix. So you multiply this inverse matrix times whatever you get over here. Now that goes way beyond the scope of a present course. It's just kind of an enrichment thing. And as I said, if I put one of these on the final exam, where you just do the matrix reduction here and find the inverse matrix and can do that, it could replace another problem you missed on the exam. Okay. But otherwise, don't worry about it.